Okay, here we go with these review questions. Again, these weren't in your packet. Just had you guys jot them down. 250 degrees radian measure. You should be able to, on your formula sheet, know how to use your formula sheet to convert that. What do I have to multiply 250 by here? Let's get it started. 19, what do I have to multiply it by? Pi over 180. I keep the pi in my answer because that tells me you're dealing in radians. I reduce 250 over 180. And that should have reduced down to not much, right? 8, what did it reduce down to?
25 over 18.
Yep. 25 pi over 18. Done. Questions there? All right. Graph an angle. Well, I don't even have to, if you ask me to graph an angle, I won't even look at it yet. But I can at least graph the initial side right here on the x-axis. Okay, what did you do to negative 2 pi over 3 to find out what quadrant it was in? Here, let's hear from 3. What'd you do to negative 2 pi over 3? Yeah, that's nice. Hey, today will be the last day you have to do that. Tomorrow I'll show you how quickly you can go from right here to nowhere and where it is. What'd you multiply by? 180 over pi. That's on the formula sheet. The pi's cancel out. This is the same as negative 120. Got it. All right, where's 120? What quadrant should 120 be in? Here we go, 20. In the third quadrant, perfect. Probably closer to 90. And Brian, what's the only thing it's missing here? Which way? Counterclockwise or clockwise? Clockwise. There we go. All good. Okay, find the reference angle now. Reference angle between the terminal side and the x, not the y, the x. So how did you find this angle right there? Remember, that's negative 120. All right, what could I have done? 7, any thoughts?
I just subtracted 120 from 90 and then got 30 and subtracted 30 from 90 got 60.
Wow. Okay, that's correct. Yeah, that's correct. I would 180 and then subtract out the angle that was right there, 120, 60. Did it get the job done? That's all we care about, right? Took a detour. That's it. You still got there. All good here, 60 degrees. Remind me again, what do you always know about your reference angle? 2 things. Always positive and between 0 and 90. Always positive between 0 and 90. Always, always, always. All right. And then finally, in radians, find a positive angle that is, I start seeing this word coterminal. I'm thinking plus or minus 360. Start adding or subtracting 360. All right. So I had negative 2 pi over 3. Now, look, if you want to convert that, add 360 to it, convert it back, that's fine too. All right. I'm trying to get you guys in the habit of staying in radians and not converting back every time. Anybody remember what 360 degrees was equal to as far as radians go? 2 pi. Yep. So instead of convert, I could have taken this right here, added 2 pi to it. Get a common denominator of what? 3. So negative 2 pi. And then what I would multiply this fraction by? Because my denominator is 1 here. What could I have multiplied that by? 3. So this would have been 6 pi on top. And we would have gotten out 4 pi over 3. I don't know if that's what you ended up with, but all right. What's up, Abe? You son of a gun. You do, yeah. Thanks. How do I do that, Abe? Yeah. You got what it reduced down to? Yep, pi over 3. Got me there. Way to go. Doesn't happen often. Quick question, and this has nothing to do with today, but going into tomorrow. Anybody see anything between the angle I started out with and the reference angle? Its reference angle? What's up, Anna? What did this have in it? Pi over 3, right? Guess, hey, if I gave you an angle of 5 pi over 3, guess what the reference angle is? Pi over 3. If I gave you negative 10 pi over 3, guess what the reference angle is? Pi over 3. Okay, so you can always tell, we'll start doing that tomorrow, what the reference angle is with whatever's attached there. All right? Okay, how do you feel here? How do you feel about all this? Because I'm going in a totally different direction today. We feel all right? You guys that were out yesterday, we had a group assignment, and for you guys that were out, it's going to be due Friday. It's at the bottom of page 8. All right, it's the textbook work on the bottom of page 8. All right, so if you weren't here yesterday, that's due back to me by Friday. All right, or it goes to 0 in the grade book. Now, there were multiple people absent yesterday, so if you guys want to group up and come in on a common time into the classroom, that's up to you guys. All right, but if you're going to do it together, it's got to be in the classroom. Okay, that's due on Friday. All good. Last announcement, and I'm sorry it has to be this way. I'm not changing it. Monday's going to be our quiz on all this. All right, Monday. It was going to be Friday, but I didn't feel comfortable with what we did last Friday, so that's why we had the group assignment yesterday, just to get everyone cleared up and on the same page. So that pushed everything back a day. So instead of Friday, it's going to be Monday, the quiz. All right. Anything you want to ask or throw out there before we go? Got a calculator in front of you? Need one of those today. Formula sheet out in front of you as well. All right, let's grind away here. We're actually going to go work in a circle today. We're going to work in a circle here. All right, real quick. In my first example, I know some of you could help me out. Radius is a length of 4, so this radius has a length of 4. And when it says intercepted arc, that means it breaks off an arc that has a length of 8. So if I draw, here you go, if I draw another radius in, that arc that it formed right there has a length of 8. How many radians would there be then? Do you remember how when I gave you those pieces of ribbon on Friday, how 1 radian was formed? When the radius equaled what? Anybody remember that? When the radius equaled the length of the arc. So if that was 4 and this is 4, that would be 1 radian. So how many radians do you think I have now if that's 4 and that's now 8? Done. Nice job. 2 radians. Yep. Okay, 2 radians. But unfortunately, it's not going to be that easy all the time, so I need to give you a formula that will show me how many radians there actually are. All right, and here's the formula. It is the following. Just let me write it down and let me explain it after. All right, theta, that's a Greek symbol we're going to be using a ton now. Theta equals S over R. Okay, S over R. Here are the different pieces, everyone. It's up here as well. You can read through it, but I want to write it out as well. S, that's the arc length. R will be your radius length. Yep. And the other piece that's new to you guys is theta. Theta, let that roll off the tongue a couple times. Theta. That's the angle. Here's the huge part I'm going to go nuts about. Angle in radians. In radians. It's got to be in radians before you plug it in. Well, what if it's in degrees? What do you have the ability to do now? Convert it to radians, okay? I cannot use degrees in this formula. Hey, quickly, can you look on your formula sheet? Anybody see this formula anywhere? Anybody see theta equals S over R? Anybody see it? Yeah, me neither. Just showing a point there. All right, that's on you. All right, that's on you. You ready to go, Trent? Good. Looking snazzy today. Nice job. I was going to say it's picture day, but I don't think so. All right. You're a senior anyway. What school did you go to, Trent? Elementary.
I went to Pittsburgh Elementary School.
Really? Wow. When'd you move here?
Like 2 years ago.
Like it?
Yeah, that's nice.
So what have you been here since 9th grade or 8th?
10th grade.
10th grade. Wow. Sophomore. Okay. Good. Looking at colleges now?
Yeah.
What are you looking to going into?
Uh,
What? I want to know something about my students. Sorry. Somebody will be up next, Trent. Don't worry.
yeah, probably biomedical engineering.
Wow. Good for you, man. That just sounds like I just have aching right now when you said that. Like how tough that sounds. All right. Anyway. Well, thanks, Trent. Good to know you. Moving on. Okay, we have a radius of 1.7 inches. Now, again, I'm drawing the diagram just so you guys can see it. I am not requiring you draw a diagram every time or at all. So 1.7 inches for the radius. Find the length of the arc if my angle is 2 radians. So there's 2 radians for the angle measure. What's the arc length? What letter represents arc length in my formula? S. So we're going to be solving for S, but I need your help plugging in for theta and R. All right, so here we go. Theta equals S over R. What's my theta now? What's my theta? Here you go. 4. What's my theta? That's my angle in radians. What's the measure of my angle in radians? That's the radius. What's my angle measure in radians? It gives it to me in the problem. 2. So 2 equals arc length I'm trying to solve for over R. 9, what's my radius length? 1.7. Any ideas how I can solve this quickly? Just calm it down. Yeah, thanks for joining class. Multiply both sides by 1.7, cross multiply. S will be equal to 3.4 inches. Okay, so that's the arc length. And could I have done that without the formula? Yeah, because if that was 2, as we saw below, the arc length must be double the radius, but that's not going to be the case anymore. Everyone all right using the formula? Oh, more reading. I know you love it. More reading. Here we go. Oh, going to the clock. Determine the number of radians that a minute hand of a clock passes through if it has a length of 5 inches and its tip travels a total of 13 inches. All right. So you got your old circle here, the old clock. Minute hand's got a length of 5 and it travels. What's this 13 going to be? What's that going to be? If I got 5 here, travels a total of 13 inches. What's 13 inches up here? Arc length, right? 13. And what am I trying to find? The angle measure it makes in radians. Yep. Okay. So theta equals S over R. I want to plug in for S and R for me here real quick. 20. Want to plug in for S and R?
13/5.
Yep, 13 over 5. Is that a huge decimal? Where I'm going to ask you probably to round it or no? No, not at all. So 2.6 what? That angle's 2.6. There's 2 ways I could do an angle, degrees and radians, but when I use this formula, the angle's always in radians. So 2.6 radians. Any issues so far? Because I'm just doing basics right now. Oh, there's the old pendulum. Remember we had a discussion on that. What was that, last week? Last week we had a pendulum. We did sequences and series. Everyone knows what a pendulum is.
Oh, I never played that game.
What?
Never played that game.
What game?
First day you go, I never play sequences or whatever. And then you said, oh, maybe we'll whip out the board at the end of the week.
Well, maybe second semester. Yeah, how about second semester? All right. We got stuff to do now. All right. Some games. Okay. Okay, pendulum swings through an angle of 0.55 radians. Oh, say this will be my what? 0.55 radians. That'll be my theta. What distance does the tip travel? Which will be what? That'll be S. If it has a length of 8 feet, and that'll be my R value. Yep. So 0.55 equals S over R, which we said was 8. How far is this pendulum going to have to travel? What do you got there, Molly? 0.4? Okay, calm down. Easy with the attitude. 4.4. Yep. Feet. Everyone all right? Having the ability to plug in for 2, solve for the third. No big deal, because I'm really going to change it up on you now in the next problem. All right, go ahead. Read through the next problem. See if you can see where my challenge is going to come here. I'm still talking about that darn pendulum going through an angle of 30 degrees. The tip travels 4 pi inches. Wow. Find the length of the pendulum. All right, find the length. Which variable am I going to solve for in theta equals S over R? Find the length. Length of the pendulum. Would that be the angle measure, the arc measure, or the radius measure? It is going to be the radius measure. So I'm going to solve for R. What's my angle? 30 what? Degrees. Can't use the formula yet. I don't want this. 30 equals. Why not? It's got to be in radians for you to use the formula. Theta has to be in radians. Is there anything you can do to 30 to turn it into radians? Darn right. That's why we've been converting the last 2 days to get ready for this. 30 times, what are you going to multiply it by? It's 8. What do you want to multiply it by to turn it into radians? Pi over 180. Perfect. Reduce 30 over 180. Okay, pi over 6. So that is my theta, everybody, that I'm going to plug in there. So theta, yeah, pi over 6 equals, what's my S and my R here? What is my arc length? Read the problem through. Arc length, 18. Four pi, yep. So 4 pi over R. You know, you can go right to the calculator if you want. We can cross multiply. So pi times R equals, what am I going to have on the right side here? 12. What am I going to have on the right side when I multiply 6 and 4 pi? I don't want that. Come on. It's just 6 times 4. Did you just use your calculator for that? I was rushing. Got rattled. It's like, hey, what's your name? And you take out your wallet and look at your license. That's what that's equivalent to. For me, anyway. All right. Don't back them up. All right? Don't back them up. It ends up, no whether you use your calculator or not, should end up, the radius should be 24. All right, 24 inches. All good? So if it's in degrees and you want to use the formula, you got to convert it to radians first. And then number 5, yeah, here we go. Steering wheel of a monster truck. Get her done. Here we go, guys. Here we go. Radius of 11 inches. How far does the steering wheel travel if the wheel makes 4/5 of a rotation? Wow. We got some discussing to do, huh? So I got, the 11 is going to be my what value? That's my radius value, yep. My R value. There's my little steering wheel here on the old monster truck. Anybody into that? Anybody ever been to a rally? I've never been, but I don't know. I've heard it's pretty loud. Loud and dirty. Anybody ever been? Because I know Times Union Center usually has one a couple times a year. Yeah? Loud?
That was a while back.
Loud?
They have rides and stuff.
All right. Not much else discussion, I guess, if people haven't been recently. So I know when I do theta equals S over R, we've already said that that's going to be 11's my R value. What are you solving for if I'm asking how far does the point on the steering wheel travel? That's going to be my what value? S, because that's along the arc, right? So I'm going to solve for S, but how the heck? I need theta. I can't have two missing variables. That's ridiculous. So how can I find that? Well, what else do we know? 4/5 of a rotation. What would a full rotation be? 360, right? So what's 4/5 then? 360 times 4/5. That's 288. Is that what I want to put in for theta? No, why not? You're better than that. It needs to be radians, so multiply it by pi over 180, reduce. So what's going in there now? It doesn't even, it reduces, doesn't it? 8/5, 8 pi over 5. Keep the pi in your answer. All right, now you guys can cross multiply. It does have rounding directions to the nearest tenth, so I'll let you guys cross multiply and do your thing. Nearest tenth, what are we looking at here? 1, what are we looking at? 17.6. Yeah? Why do I have something different on my paper? I'm not going to tell you. I do not have that. Okay. Oh, never mind. Nope, I'm wrong. Nope, I'm wrong. I had one jab. I'll find out in a second. 8 pi times 11. That's 8. No, it's not. It's because I divided by 360 instead of 180 for when converting, because I just teach it. I don't have to know how to do it. No big deal, right? But you know what? 8th period, I look like an absolute genius. 55.3? No? Yes? I use the thing called a fraction template.
Yeah, no, I did that too. 288 over 180 is 8.
8 pi over 5, right? What's that?
No, you're right.
Yeah, so I did 8 pi times 11 divided by 5, right? Little thing, cross multiplication. We all good?
Yes, you are correct.
Okay. Got to have the pi in there, yep. Okay, all good? Questions? Okay, plenty of time. We'll get this finished right now. Go ahead, grab the textbook. Let's get going. Page 802.